Okay, so can I draw your attention again to the screen? Now, let's suppose that we get presented with a matrix transformation again. But let's suppose this time that the matrix transformation is something like this, okay? So we have a matrix transformation which is, and I'll just write it, I won't bother color coding it, 2, 0, what is it, 1, 0, 1, okay? So it's some matrix transformation. Now, this case, all I'm interested in is how many times bigger my new shape is, in other words, the one in green, compared to my old shape, the one in black. So what was the area of my old shape?
Just 1?
Yeah, absolutely. So the old area of my old shape was 1. What's the area of my new shape?
2.
Absolutely, and you can see I've written that on the right-hand side of the screen. Okay? Now, here's the thing. What if I didn't want to draw it? What if I said this is a matrix transformation, and I wanted you to be able to tell me how many times bigger my new area is going to be compared to my old area once I've done this transformation? Okay? I can do that really easily from this. Let me show you how. So let's suppose this is my matrix, my transformation matrix. Okay? I can do it using this idea of a determinant. So determinant, which I can write as this. Okay? We've looked at determinants before when we did our when I did our vectors, right? When I was doing my cross products of vectors.
Yeah.
Yeah? This is literally a determinant. So a determinant will tell you how many times bigger my new shape is going to be compared to my old shape. Okay? And the way which I calculate it, you might remember, is I take these two elements and I multiply them together, and I subtract the product of these two elements. Okay? So in this case, I get 2 times 1, and I subtract 0 times 0. What's that equal to?
2.
2. So whatever happens, whatever shape I start off with, and I can do a weird and funky shape if I want to. Okay, so if I start off with a shape which has an area of 1.5, okay, if I apply this transformation matrix, my new shape is going to be twice as big. Okay, that's literally what the determinant tells you. It tells you how many times bigger your new shape is going to be relative to your old shape. Okay, so if I give you a matrix like, this, okay, how many times bigger would my new shape be compared to my old shape? So what's the determinant of this matrix? By the way, that's another way of writing determinant. What's another way? How do I calculate the determinant of the matrix? 3 times 1 minus 2 times 0, which is equal to 3. Okay, let's test it out. Let's test it out. Okay, so if I change it, so it's now 3, 0 and 2, 1. So there. Are you happy? Oops, went a little bit too far. Are you happy that my new shape is now 3 times as big as my old shape?
Yes.
Okay. Now, there's one particular situation which you need to be careful of. For example, what if I have something like this? Okay. What if I have something like this? So in other words, my new matrix, let me get rid of it. Okay. My transformation matrix is, what is it? 4, 2, 2, 1. Okay. Now you can see, just look at the transformation first of all. You can see that my old shape was a square. What's my new shape now? Sorry? It's just a line, yeah? It's just been squashed into a line, okay? Now, have a think. What's the determinant of this matrix? Yeah, the determinant of this matrix is going to be 4 times 1 minus 2 times 2. Which is 0, okay? That makes sense. So if I have a determinant of 0, what that literally means is that my old shape has just been now compressed into a straight line. So it's no longer two-dimensional, okay? No longer two-dimensional, right? We will revisit this idea again later on, okay? By the way, if the determinant comes out as negative, all it means is that there's been a reflection which has happened as well, okay? But effectively, determinants are a really useful way of telling you how many times bigger your new shape is going to be relative to your old shape.
Is it possible to say that if we have a diagonal matrix, then our area would be 0? Or
It's a diagonal matrix.
I mean, like this one.
No.
Oh, okay.
No. Okay. Effectively, a determinant just tells you, that's all I want you to take away, a determinant will tell you how many times bigger your new shape is going to be relative to your old shape after you transformed it. If it comes out as 0, all it means is it gets compressed into a straight line. That's it. Okay? All happy? Yes. Fantastic. We'll meet this again on Monday. Okay? So thank you very much, and we will finish off there.